But we can also express values in scientific and engineering notation. So let's talk about scientific first. The scientific notation is basically a shorthand way of expressing extremely large or small numbers. As a product of a number which we'll call no, I'll mention in a second. Between 0 and 10, and a power of 10. So you'll have some number times a power of 10. It's just the rule says that that number, which we're going to call m, needs to be between 0 and 10. It cannot be equal to 0 or 10. So mathematically, the symbols would be m. The scientific notation would be written m times 10 to the n, such that m is between 0 and 10. But there is no equal to part, right, in math notation. So 0 is not cool, 10 is not cool, but everything in between is fine. All right? So the idea is you're giving some number, and you have to rewrite it as some number m between 0 and 10 times the power of 10 that will make it 456. So scientific notation says this will be, so I'm going to move the decimal point 1, 2 to the left. If I move it to the left twice, that will be 10 to the second. So 1, 2. Does that make sense? So you multiply on your calculator, this will get you back to here. Okay. Notice how m is before 0.56, so this number is not 0. This number is between 0 and 10, but not 0 or 10. So that's fine. So that needs to be always below 10. Okay. So now going in the other direction, if I move the decimal point 1, 2, 3, 4, so that would be 2.1 times 10 to the negative 4. So if I go to the right, negative power. If I go to the left, it is a positive power. Somebody's waiting. So I'll put that in English. So going from standard to scientific notation, the following will happen, right? So if I move the decimal to the left, then the exponent is positive. I'm gonna put, that bothers me. I'm gonna put if in there instead of an arrow. So if we move the decimal to the right, then exponent is negative. Oops, I don't know the screen there, sorry. Okay. Okay, then do a couple more examples. 47,000. In scientific notation, what do you think the exponent will be, positive or negative? If I move it from here, which is, when you don't see a decimal, you assume this is at the end. 1, 2, 3. Yeah, it's going to be positive. There we go. Okay. Do one more. Okay, this guy, I'm going to move it to the right, so it's going to be, what will the power exponent be, positive or negative?
Negative.
Yeah, it's going to be negative, right? So 1, 2, 3, 4, 5, 6. So I stop once that m is less than 10. I said 6, right? 1, 2, 3, 4, 5, 6, yeah. Okay. So far, you guys are cool on the basic concept, yeah? Or no?
We're good.
Yes.
Okay. So let's go the other direction then. Yeah, I'll write it over here. Going from scientific to standard notation. Okay. So if the exponent is positive, then move the decimal to the right. If the exponent is negative, then move the decimal. Did you say decimal point? Well, that's fine. To the left. Okay. We'll do a couple of these, and then we'll move on to engineering notation. Okay. So 5.7, actually, let's make it 2738 times 10 to the 3. So that will be, just telling them to move the decimal point 3 times to the right. So 1, 2, 3, 527, 3.8. And the negative exponent. So this time you don't see the zeros, so we have to add them ourselves. Okay, so I think 5 might be fine. So now we'll have to add more. So 1, 2, 3, 4, 5. So the new number is 0.0, it's 4 zeros, 6, 4, 5. So going the other direction, you just got to add some zeros. Usually the numbers, if you have negative 5, then add 5 zeros. That should cover you. Excuse me. They come out of focus. Okay, so engineering notation. So this is similar to scientific. But only uses powers of 3. And what I mean is stuff like this. Negative 3, I guess technically 0 would be cool. 10 to the third, 10 to the 6, whatever, forever. Either direction. So as long as it's divisible by 3 or 0, number 0, I mean, it's fine. And we do that because a lot of the prefixes like micro, kilo, etc. Usually those change every power of 3. Centimeter, kilometer, etc. This is mainly used when dealing with prefixes for units of measure. For example, so let's do one here. So 0.0012. So the goal is not to make the m less than 10 anymore. The goal is to pick the smallest number with a power of 3. So I'm going to go 1, 2, 3, 4, 5, 6. So I'm gonna write that better. I'll write that in the next step instead of messing up the question. Sorry about that. So I'll move it here. So I added an extra 0, just so I can say 120 times 10 to the negative 6. Give me one moment, please. So as long as this is divisible by 3, then it's fine. I won't fault you for choosing either or. The scientific, though, is more strict in that this piece right here before the x or the times, it needs to be less than 10, but not so much on this guy, these steps. Okay, so we have 19,300. So 1,300, that will be decimals over here. So 9,300. So 1, 2, 3. So that will be 19.3 times 10 to the third power. Anyway, is there any questions on engineering or scientific? Okay.